All right, welcome back everybody. This is Mr. Mace and I'm here today to go over Unit 5, Lesson 11 with you. That's going to start on page 265 in your Math Expressions book. And we are going to be covering constant rates of speed or constant unit rates. Again, kind of a review lesson from earlier in the year, or at least piggybacking off of one of those lessons that we've done earlier in the year, maybe taking it a step farther and putting it a little bit of an algebraic spin onto those lessons that we did earlier, talking about how to create constant unit rate tables and so on. All right, so if you look at the top phrase here, you see we've got two students and they are walking at a constant rate of speed, not the same rate of speed, but they are each walking at their own constant rate. One of the students, student 1, is walking at 3 feet per second, and student 2 is walking at 5 feet per second. Okay, we know that it is a constant unit rate because it is per second, which means for each and every second that they are walking, they are going to cover that distance. All right, and so the time and the distance are important to us as well, because when we start creating these algebraic equations, we need variables. So we're going to point out the variables to you right here as t and d. T standing for the amount of time that those students walked for, and d being the distance that they traveled because of that time, okay, or after they walked that amount of time. I'm going to skip over the number line here for just a second and come back to it. The two variables, we've got a dependent variable and an independent variable. The independent variable, I'll start with that, is the amount of time. T in this case is the independent variable because we can determine how long these students walk for. We can just pick a number and go with it, and it does not matter what we choose. We get to determine that variable. But the dependent variable means it depends on how long the students walk for before we can put a number in for that one. So the independent variable t, I can pick a number and place it in there, but the d depends on the amount of time that they walk for, and it depends on the coefficient, how fast they were walking or how much ground they covered, okay, for each second. So dependent variable is going to be our d. The t is our independent variable where we can pick the number that goes in for that. All right. The number lines that we have up on top here are just basically illustrating that this is a constant rate of speed. Student 1, you can see that after 1 second they have traveled 3 feet. After 2 seconds they've traveled 6 feet, 3 seconds 9, 4 seconds 12, and 5 seconds 15. Again, skip counting by threes. You can see that student 2, after every second, has gone up 5 feet. So 1 second 5, 2 seconds 10, 3 seconds 15. And so that is, again, another way to determine that this is a constant unit rate moving up here. We know that it's a unit rate because they tell us it's per second. They didn't say that the student travels 7 feet per 2 seconds or 7 feet per 3 seconds. That'll come a little bit later in the lesson. So right now we are dealing with starting at the unit rate and branching our way out, trying to establish what we are, how to set up these equations to move forward. All right, so it says, can t or b be whole numbers? Well, obviously we're looking at them being whole numbers right now, but can they also be fractions or decimals? Yes, they could. As we move forward here, you're going to see that depending on what we are using for our unit rate, we might end up with some mixed numbers, we might end up with some decimal numbers. Okay, and we're also going to show you just very briefly how we might graph this information and determine if it is a constant rate. We're going to have some unit rate triangles and some different things that we can establish as we look at that. But that's, again, a pretty straightforward concept I believe that we've covered to a certain extent already. All right, let's take a look at page 266. And you can see that we're going to take the information from the last page, and I'm going to copy some of that on the top here, just so we don't have to keep flipping back and forth. Take the information from the last page and transfer it to what we call a table. All right, and you've got a table here, or I have referenced it with my kids as an input-output table, where I put a number in and I get a number out on this side. So in and out. If I put this number into the equation, I get this number out for my dependent variable. All right. But we know that student 1 walked 3 feet per 1 second. All right, so that is our kind of our rule, kind of our input for that. For every second that the person walks, we're going to go up by 3. The second student walked 5 feet per second, per second. Okay, got a little ahead of myself there. All right. So as we start to fill out this table, one thing should be clear, one thing should be even on both these charts. If neither of these students have walked for any seconds, they've walked 0 feet. So both of these are going to start at 0, 0, and that again is very important when we get to our graphing on the next page, that we need to start our graphing line at 0, 0. All right. Now is where we're going to start to defer and branch off depending on the student we're dealing with. So after 1 second, student 1 will have walked 3 feet. So D in this case would be represented by a 3. The T would be represented by a 1. If I put a 1 into the second one, he's going to have walked 5 feet if he's only walked 1 second. All right, and you can see that because of the unit rate that we have established already. And now I just go down the tables and I start skip counting by that rate. So in this case, after 2 seconds, 6, after 3 seconds, 9, 12, and 15. And for the second one, because it's a unit rate of 5, I'm going to skip count by 5. So after 2 seconds, he's going to have traveled 10 feet, 3, 15, 4, 20, and 5, 25. All right? And because it is a skip counting pattern like that, we should recognize that our equation that we are eventually going to set up here using algebraic variables has to be a multiplication. We are skip counting, right? So it's going to be a multiplication expression, or excuse me, equation to set this up. Now we know that D is the determinant, or excuse me, the dependent variable. D dependent. So we know that we don't know D until we solve the other side of the equation. All right. The other thing we don't know at this point, or that we can possibly change, is the amount of time that these students walked for. What we do know, the part that we do know, is what we call the coefficient, or the answer to the next question says, how is each student's walking rate related to the equation? Okay, well, their walking rate is going to be 3 for student 1 times the amount of time he walked. Student 2 is going to be a 5 times the amount of time he walked, the amount of seconds he walked. All right, so these numbers out front, if you remember back to a few lessons, we talked about those standing for the term coefficient. So that is the coefficient in our equation. Then I just simply need to take a number from the T column and plug it in to the equation to figure out what the D would be. Now, this is an easy one, right? This is easy numbers. So if I take the 2 for student 1, I take the 2 out of his column and plug it in for the T, we know that D is going to equal 6 because 3 times 2 is 6. And if I look up here, if I put a 2 in for T, it equals 6 when it comes out the other side. Same thing for student 2. If I take a number from this T column and I plug it in, let's say I plug in the 4 and I plug it in here, we know that 5 times 4, D has to equal 20. And in this case, it does. So that's how the equation would work each and every time, and we establish that equation. So if we get a number that's a little bit bigger, let's say that they chose to walk for 30 seconds, right? If we said student 1 wants to walk for 30 seconds, how far is he going to have traveled? Well, now we take 3 times 30 and realize that he has walked 90 feet. Or if we say for student 2 that he wants to walk for 60 seconds, okay, he's going to walk for a full minute, we plug 60 in for T, and we realize that 5 times 60 is 300, and he's going to have walked 300 feet. So we can make this an easier problem by setting up the equation and not having to do the table and skip count all the way through to determine that. All right? And I promise you that the equations will get a little harder than what we're seeing here right now, but we're definitely trying to establish what the routine is and how we make this work. Now we're going to take this information on the tables and we're going to transfer that to a graph. Okay, pretty straightforward stuff. We take the left column, which is our independent variable, and that will always go horizontally. The first number in the table will always be our horizontal. Remember, we go over and then up. So as we look on the next page here, you can see our graphs. First we go over, seconds elapsed, and then we go up depending on what the unit rate is. All right, so for student 1, which is the first graph here, if at 0 seconds, he's gone 0 feet. So we're right in that corner, 0, 0. But if we look back at the table, I don't need to, but if we look back at the table, and after 1 second, I've bounced over 1, he has traveled 3 feet. And at 2 seconds, I'd go up another 3, and he would travel 6 feet. I go over to 3 seconds, and he would have traveled 9 feet. And when I'm all said and done creating that entire chart, I would draw a straight line, as straight as I can on a smartboard, to create that constant rate line. And again, to be constant means I need to have unit rate triangles that are the same all the way going up, and I'll show you that in a little bit. All right, student 2, again, we still start 0, 0, because after 0 seconds, he's gone nowhere. But after 1 second, instead of going up 3, he's gone up 5. So our line is getting a little steeper, getting a little taller. After 2 seconds, I go over 1 and up 5 more to 10. After 3 seconds, he's up to 15. All right, so if I look at this line and I'm comparing the two, this one's going a little bit more straight up than my other one, which simply means he's walking faster, which we already knew. But now I want to take that information and I want to show my unit rate triangles. If you remember all the way back a couple lessons, over then up, it should be over 1, up 3. If it's constant, it is the same size triangles all the way. Over 1 and up 3. Over 1 and up 3. So notice how I'm making those even triangles going up. It is a constant rate. Same thing here. Over 1, up 5. Over 1, up 5. Over 1, up 5. And those triangles are all obviously as similar as they can be, writing on a smartboard, and how straight your line can actually be. All right, now that's what happens when they give us the unit rate. They tell us how many feet per second. But sometimes, like I mentioned earlier, they will actually give us a unit rate, or not give us the unit rate, and we have to find the unit rate. So I'm going to have you jump ahead a couple pages here to page 269, where we have to now find the unit rate of what we are working with here. And they tell us now that we've got another student, this is going to be student 4, who walks at a constant rate, still constant, of 7 feet for every 2 seconds. Notice this is not a unit rate anymore because it is per 2 seconds. So our double number line here isn't exactly the same either, because at 1 second we don't know how far he's walked yet. They haven't given us that information, but at 2 seconds we do know that he's walked 7 feet. All right, so now how am I going to figure out how far he's walked for our unit rate? How am I going to figure out how far he's walked here? Well, it should be half of 7. So however I want to represent that half of 7 will determine what that unit rate is. I can either represent it as a decimal number, or I can represent it as a fractional number. Doesn't matter to me either way. Whatever's easier for you to work with. I like working with fractions right now, so I'm going to say 3.5. So in this case, our unit rate for this student, 4th student walker, is going to be 3.5 feet per second. All right. Now if I come all the way out to 4 seconds, I double up that 7. Okay, I'm coming all the way out here. Now I'm out to 14 because I got to double the 7, not the 3.5. Okay, and you're going to notice on our table here that we're going to have a few more fractions than just the 3.5. At 0, yep, still going to have walked 0 distance. At 1 now, though, we've determined he's going to walk 3.5 feet. Or she, shouldn't say he. At 2 seconds, we know, that's the one they gave us, 2 seconds, we know that he's walked, or she has walked 7 feet. The next one now is going to be 3.5 more than 7. Remember, we're going up by 3.5. Okay? So now it's going to be 10.5 if I skip count by 3.5. Okay? Next one again is going to be a whole number like we just showed on the number line up there. At 4 seconds is going to be 14. And then the last one here is again going up 3.5 to 17.5. So again, still a constant pattern, still going up. Now, what is the unit rate? Well, I've already mentioned that for you. That means that this student has walked 3.5 feet per second. Remember, we want how much it is per each and every second. That's the unit rate. Unit means 1 for every 1 second. All right, and then how would we write the equation? Same way we wrote the equation before. All right, we want to take this information and we want to say that how far they walked is going to be determined by how long they walked times the unit rate, in this case 3.5 seconds. So I want you to take that equation and I want you to try to answer the 2 questions down below. Okay, calculate how far student 4 walks given the length of time. So the first one is 3 seconds and the second one is 2.5 seconds. I want you to try to figure those out, and I'm going to give you a really short video coming back to just kind of wrap up and reinforce this concept before your assignment. All right, so good luck on questions 16 and 17, and I'll see you back for the second video.